Hello dear students. So this is our another lecture on these differential equations, and our main focus is to solve the problems related to the differential equations. The differential equations can be homogeneous or inhomogeneous differential equations, and we have already discussed in our classes that how we distinguish between homogeneous and inhomogeneous differential equation. And we can have a linear differential equation or some differential equation which are not linear, or we can have this homogeneous as well as inhomogeneous differential equation of first order as well as second order, right? So this is you are very much aware about it, so I will not discuss these things. So our main focus will be on only on the problems related to those differential equations, and those equations can be homogeneous or inhomogeneous. They can be first order or they can be second order, right? So if you so the first problem that is related to the differential equation. So that is basically the problem is that the radioactive decay or radioactive nuclei or radioactive decay of nuclei according to this law, that's dN by dt equal to this thing, that's equal to minus lambda of n, where n is basically the concentration of that nuclei. It basically decay according to this formula, and is basically the concentration of a given nuclei, and lambda is our decay constant. And so for n different nucleides, because if we consider for n different nucleides, so for n different nuclide starting with n1, so n1 is basically the first, that's the concentration of first nuclide. So it decays according to this law, that is dn1 by dt, that's equal to minus lambda 1 n1, right? And similarly the second nucleide, so that decays according to this reaction. So it is given, right? And so what we have to calculate? So we need to calculate that, find n2 of t for the condition given that n1 of 0 equal to 0 and that n2 of 0 equal to 0, right? So we need to use these conditions, initial conditions, because we have that constant of integration when we integrate our given differential equation. So we have some constants. So in order to get the value of those constants, so you need to use some initial conditions. So those initial conditions are given, and we need to find that n2 of t. So that means we need to find the concentration of that nuclei at some time t, right? So again, let us check now. So if we have a look on this, so suppose because we are saying that जो हमारा first nucleide होगा, so that basically obeys this equation, this differential equation, right? So that means dn1 by dt equal to minus lambda 1 of n. So or you can write this as, so this is simply that homogeneous first order differential equation, right? So we know that how to calculate a solution. So either you write the general solution for this homogeneous first order differential equation. So that is basically that if we have some dy by dx. So first let's find that. Okay, so we know that. So first let me write now as, so is it that minus lambda, right? Okay, or you can rewrite this as uh, or you can write this as dn1 by dt, right? Because this is basically that we have this dy by dx plus dx of y, that's equal to 0. So this is our homogeneous first order differential equation, and its solution will be some p of x will be equal to, that will be equal to some a e power minus integral. तो इसको मैं ऐसे इस फॉर्म में भी लिख सकता हूँ, और आई कैन डायरेक्टली इंटीग्रेट दिस इक्वेशन, this equation, and find that n1, that is concentration of first nuclei, right? So if you integrate this equation, that means, तो यहाँ पे मैंने क्या किया, I basically take that, sorry, this is okay. So what I did here, so now you divide that n1 on this side, right? So it will be d1 by n1 equal to this, right? Now we integrate this. This is because you have integration of dx by x, that's log of x, right? So this will be that log of n1 So that's equal to minus. Okay. Or you can write that. So before that, okay, so you can rewrite this as n1 will be equal to, so that will be equal to, this will be equal to that e power minus lambda 1 of t into e power c. Because this is that e power again some constant, because the value of e is some 2.71 and raised power that c, that's constant, it can have some value, some constant value, so it's again a constant, right? So that I can write it as, let's put a e power minus lambda 1 of, so that's this clear. Okay, so A is again constant, and that can be that N0, right? So the initial concentration of that nuclei, right? So I calculated N1, but if you remember that, so our question says that we need to find that N2 of T for the condition. So we need हमें calculate करना है the concentration for the second nuclei, provided the condition of that N1 of 0 equal to 0 and that N2 of 0 equal to 0, right? So first let us calculate now N2 of, because we have one more relation, right? So I can rewrite this as, so N1 is clear, right? So similarly, if you calculate from the initial condition, so because we need to calculate this constant, so that means, so from initial condition, that is that N1 will be equal to, okay. So that means, so ये equation क्या बनेगी? So that means this equation becomes, so it will be that N1 will be equal to N0 e raised power this. So that means our N1 will be, or N1 of t, N0, because you will get here, because you get that c equal to that N0, right? So that's, and similarly, so this we have calculated that N1 of t. Similarly, if you calculate that N2 of t now, so because we know that, so from our this condition, so we have this equation. So this is basically the equation for this second nuclide, that is dn2 by dt equal to lambda 1 n1 minus lambda 2 n2. So let's use this equation and solve it for n2. Right? So that means also we have this. This will be equal to, okay. Now this time, if you remember that, because we are differentiating it with respect to that n2, so where, so this is some. So if you check that, so this is now, this is not homogeneous differential equation. It is inhomogeneous differential equation, and because we have some, it is some, it is in this form. So we have the general form for inhomogeneous differential equation. So that is dy by dx. Okay. So this is the general form for this inhomogeneous differential equation. And if you make a comparison here, so because it is in this fashion, so you can write that, so our p of x will be equal to lambda 2 and our q of x will be lambda 1 n, right? So that means I can write that here p of x will be equal to, it's N2 of 2 because it's a function of, so it is basically the concentration of those nucleides at some time t, right? So or you can write that y of x, or this is N2 of t, right? So better is to write, if you write here y of t, and this will be N2 of t here. Okay, this is y of x because it's a y is a function of x. We can write this, or you can write this here also, right? Okay. Now if you know that, so because आपको already पता है कि जो हमारी ये differential equation है, the general this form of this inhomogeneous differential equation, and you know the solution for this differential equation. We have already calculated, so how to calculate that the value of this y of x, how to calculate the solution for this kind of differential equation. And it will be, some y of x will be that that e raised power minus integral, that's integrating factor, e raised power minus px dx, and so let me write that. Huh? So the solution for this inhomogeneous differential equation will be, that means y of x will be equal to, so that means this is the general solution for this differential equation. So that means ये हमें already पता है कि जो हमारी ये differential equation यहाँ पे है, that is dn2 by dt plus lambda 2 equal to lambda 1 n1. So it is of the same form. This, it's inhomogeneous again, this differential equation, and the solution of this form will be of this way. So that means in this form. But we already know when we compare them. तो जब हमने compare किया था, when I compare this equation with this equation, तो because हमारा जो d by dx यहाँ पे d by dt है, तो that means जो हमारा y है, that's n2 of t, and जो हमारा p of x है, that's lambda 2, and then q of x equal to lambda 1 n1, right? So that means we can write directly the solution, right? No need to derive that because we have already done that in our classes. So better is to write directly the solution for this kind of differential equation. Okay. So that means we can write here. So because y of x will be of n2 of t, so n2 of t will be equal to, so that will be equal to e power. So what I wrote here, it is lambda 2, sorry. Okay. And this q of x, so q of x is equal to, so q of x is our lambda 1 into dt. Okay. So let's integrate this. So that means, now, but you know that this n1 we have already calculated. That n1 is basically, so n1 we substitute this value because our n1 equal to, that's equal to n0 e raised power minus lambda 1 into t, right? So let us use this. Let us use this result A in this equation. In this equation. So this is our equation B. Okay. So हम जो value n1 का है, so that I will substitute in this, in equation B. So that means we will substitute, use equation A and B. So that means n2 of t will be equal to, Is it okay? So that's, so I simply substitute that n1 जो हमारा था that was n0, so that was n0 but this is minus lambda. So you just check that. तो आप check कर सकते हो why it is fine. So that's n1. So n1 equal to n0 e raised power minus lambda 1 into t, right? So I use this value of this n1 in this equation b, right? So हमारी equation b थी that was n2 of t equal to e raised power minus lambda 2 t e raised power lambda 2 t into lambda 1 n1 dt plus c. तो यहाँ पे n1 के बदले मुझे लिखना है that's n0 and lambda 1. तो lambda 1 यहाँ पे multiply कर दें. So that means I can rewrite this as okay. So because n0 is basically the initial concentration at t equal to 0. So what is the concentration for this first nuclide? So that's basically n0 at t equal to 0, right? So this is basically the initial condition. What is the initial concentration of that nuclide? So we can rewrite this as, because you can take that out and lambda 1 is constant. We can write that lambda 1 n0 okay, or you can write this as so sorry, this is integration here. Okay, integration. Huh? Why I am taking, because lambda 1 is constant, that is decay constant, and n0 is the initial concentration. So इनको मैं बाहर निकाल सकता हूँ. I can take them outside that integral. So that's what I did here, lambda 1 n0 out. And we need to integrate only this part. So you write that e raised power, that's lambda 1. You can combine them, right? So you can rewrite this as e raised power lambda 2 minus lambda 1 into t, right? Into dt plus c. So when you integrate this equation, you can get same thing now. So that's all. Okay. Now we need to calculate this constant of integration. So again, using the initial condition. So initial condition हमारी है at t equal to 0. उस time जो हमारा n1 of 0 that's equal to n0, but n2 of 0 equal to 0. So you just check that. So let me check those results. So because the question says that here n1 of 0 equal to 0 at t equal to 0, जब हम t time 0 लेंगे उस time पे जो हमारा n1 of 0 equal to 0 and n2 of 0 equal to 0. But it is at t equal to 0, right? So this is very important, that t equal to 0 and n1 of 0 equal to n0 and but n2 of 0 equal to 0, right? So using this initial condition, in order to calculate the value of that constant of integration in this equation. Okay? तो यहाँ पे मुझे क्या करना है? So using from initial condition, so हमारी initial condition क्या है? That at t equal to 0, हमारी n2 of t will be equal to 0 because t will be 0, so n2 of 0 equal to 0. This is purely from the initial condition. तो जब हम ये सबस्टिट्यूट करेंगे इस इक्वेशन में, because n2 of t will be 0 in that case and this will be same thing, but t equal to 0 here, right? So it will be e raised power 0, right? It will be equal to 1. And similarly at t equal to 0, so this term will be e raised power 0. Anything raised power 0 except 0 equal to 1, e raised power 0. And in the denominator we have lambda 2 minus lambda 1 plus c, right? So let me write that. So I can rewrite this term as, so that means 0 equal to that's equal to e raised power 0. So what was lambda 1? what else is there? So there is that. So this will be e raised power 0 lambda 2 minus 1 plus c. Okay. So that means our c will be equal to that's equal to minus 1 divided by lambda 2 minus lambda. Okay. Right. So substitute in this equation. So use that value of c here. So ये c हम यहाँ पे substitute करेंगे this equation में, यहाँ पे in this equation. So substitute value of c in this equation, that's minus 1 by lambda 2 minus 1. Use it here. Huh? So that means जो हमारी equation है, so use so above equation, that's m2 of t m0 e power minus lambda 2 of t, and inside will be e power lambda 2. Okay. तो सिंपली मैंने यहाँ पे यूज किया, राइट. और इसको मैं लिख सकता हूँ, आई कैन राइट दिस एज इट विल बी lambda 1 and 0 and or I can rewrite this here. तो मैं क्या कर रहा हूँ यहाँ पे मैं I take this term out, that's 1 divided by lambda 2 minus lambda 1, so that is there. तो जो lambda 1 m0 है that was already outside this bracket, right. अब मैं ये multiply करूँगा यहाँ पे, when I multiply this, so this is e raised power minus lambda of 2 of t, but this is e raised power plus lambda 2 of t minus e raised power this. तो इसको मैं लिख सकता हूँ ना, I can write this as e raised power lambda 2 of t and into e power minus lambda 1 of t, right. तो इस टर्म को मैं लिख सकता हूँ, तो when I multiply this to this term, तो ये टर्म बन जाएगी e raised power 0 equal to 1, only this term will survive, तो ये टर्म रह जाएगी. So that means inside will be e raised power 1 of t first term and second will be e raised power minus lambda 2 of t. So this is our n. So this was basically that what the question says, that we need to calculate that n2 of t. So provided the condition is that n1 of that 0 at t equal to 0, but n2 of 0 equal to 0 at t equal to 0, right. So giving those conditions, because we need to calculate that constant of integration, so initial conditions are very important, right. So it's a kind of initial value problem, and finally we need to calculate that n2 of t, right. So hopefully in our coming lecture I will discuss some more problems on these differential equations. They can be homogeneous or inhomogeneous, and I am basically taking these problems from Rifkin and Weber. So just check some page number, I don't remember it, but I can mention in our coming lecture. So hopefully we will discuss some more problems related to these differential equations. Thank you very much.